W. Curtis Preston from Tribit TV. I'm talking to Dmitry Yusupov, founder and chief architect for Nexenta. How's it going, Dmitry?
It's good, thanks.
So thanks for taking the time. This is a big event. I'm sure you're very busy.
Absolutely.
So you are you the original architect of the Nexenta product?
Yes, I'm one of the original architects.
Right.
Together with Alex, we started the company back in 2005. And since then, we built a product. The product was on the market in 2008. This is where our first sales starting to happen.
So I was a few minutes ago. I was talking to Robert Novak, and we started talking about. We started getting a little geeky, right? I'm a geek at heart,
All right.
right? And we started talking about. He kept referring to how the entire storage industry is still based off of an architecture that was developed 120 years ago, right? The punch card, the block,
Right, yes.
right? And that we're looking at something new coming around the corner, the key value idea.
Right.
Why don't you tell me a little bit about that?
I can talk a little bit about key value idea and how the world is changing. I think the most drastic change, what is happening is in the storage industry, is that now today with advancements of the x86 servers and modern hardware, you actually not necessarily need to develop specialized hardware at all. You can do everything in software, and that's how we started the company. We believed in the idea that we can deliver the feature set of the enterprise storage device, doing everything in software. So that's the promise of Nexenta. That's our original product, which we built back in 2006. Again, was Nexenta Store, and that was software-only solution to deliver a scalable NAS and SAN storage. After that, we started to focus on object storage, which is a new generation storage, next generation product called Nexenta Edge. And primarily what it's about to deliver is a scalable and scale-out object which can leverage such devices as a key value devices. The benefit of those is that you can address storage by simply calculating cryptographic hash and getting the data right away without actually going into the intrinsic complexities of the getting this through the standard ways such as SAS and HBA technologies. So with that in mind, the Seagate last year announced the key value drives which can be addressed immediately over the Ethernet. So that means there is a pass-through from the kernel standpoint, from the application standpoint. It can access the key value drive directly via IP address. That is a significant change in what's going to happen. Today it's just a few, but we do see appearance of more and more devices supporting key value paradigm.
Right.
And we're going to capitalize on this.
What does that provide to you? Like, so once this comes, completely available, what advantages does that give to you?
First of all, they're much easier to manage and multipassing. So you don't need to actually be so worried about how the device connected to the host. It's literally connected over the switch. It's available somewhere on a fabric, somewhere. You don't even actually have to worry about where is it available. As long as there is a switch infrastructure properly connected, the device will be there. So that means in case of failure, the another node just simply can address the same device and talk to that device independently.
Yeah, and I know when I was talking to Robert, he talked about this idea that a drive could go offline for a short period of time, and you wouldn't care because you're simply asking for who has this key value pair, and any drive could answer that question.
This is one of our patent technologies, which is of Nexenta Edge product. Indeed, the idea here is that we can, because we know the cryptographic hash up front, we can actually just simply ask who has it. And those devices are very, very handy because they can now recognize that request because we built our own protocol which actually can talk to those devices and say, hey, I have it. And if one of the devices temporarily down, it's just not participating in that negotiation. So the beauty of this design is that negotiation done dynamically. So dynamically at the microsecond resolution, kind of. And that is actually kind of very revolutionary idea because All other approaches down there, they cannot negotiate that fast. And
Right.
what we're trying to achieve to negotiating down to the microsecond level and do this as it goes. With that approach, we can build highly scalable solution which can scale out to the multiple petabytes with a deduplication in place. So if you're aware of what deduplication is, that is significant data reduction piece. And the challenges today is that if you do deduplication and if you implement it with today's technologies, you have to have a centralized database, and each time you initiate I/O, you need to actually ask the database, do you have that particular chunk or not? And if you don't, then and that basically takes time, and that database is centralized, and so it creates a point of failure and so on. So and also slow. When it goes to the petabytes of data, you want to apply the same practice. You cannot do that efficiently because it just doesn't scale. So with our technology, we should be able to scale to the multiple petabytes without significant degradation on performance.
It'll be really interesting to see what you and and your competitors do with this really interesting paradigm shift in how data is stored. So thanks for taking the time to talk today. And thank you for watching. Again, make sure to check out our other videos on TrueBit.tv.